Alright, so I'm going to click on Save, and then click on the Build button, build this program. So that's compiling and linking it, and now we'll run it. So down here on the console it says enter the seed color, so I'm going to enter in red. Enter the temperature, I'll say the temperature is 85, and the soil moisture is dry. So it outputs a dandelion will grow, and is that what we expected? So if we go back up here to the paragraph dealing with the red seed, if it's above 75 degrees and the soil is dry, then it's going to produce a dandelion. And that's what we expected, and if you look at our logic, that's exactly what happened. So we had a red seed, temperature was greater than or equal to 75, and the soil moisture was dry, so it outputs a dandelion. So very basic stuff here, and hopefully that makes sense. Let's run it one more time and just test out another path of execution here. So we'll run this. This time we'll type in blue, and we'll say the temperature is 45. And enter in the soil moisture, wet. So it says a mushroom will grow. So let's check that out and make sure that that is true. So if we have a blue seed, and for a flower to grow, it has to be between 60 and 70. In our case, we had 45. And then it says that, so if it doesn't meet this temperature range here, then it will grow a mushroom. And that's exactly what we got. And we can look at our logic to confirm that. Blue, so the temperature was not between this range. So we ended up with the else. So we tested this here. This turned out to be false. So it ends up doing whatever we have here in the else operation. So mushroom will grow. Now something that you probably noticed here is that we're actually asking for the soil moisture after we've gotten the temperature. And there's really no reason to ask for the soil moisture if we know that we're going to end up with a mushroom. So that's maybe something we can go and change in our program. Okay, so let's look at moving this code here where we get the soil moisture down to the point where it actually matters. So we're going to move these 3 lines of code down below, in the case of the red seed, after we know that we have a temperature greater than or equal to 75, because only at that point in time do we take into account the soil moisture being wet or dry. So if we fall into a situation where our temperature is less than 75, we know that we're going to get a mushroom. It doesn't matter what the soil moisture is. And it's the same case with the blue seed. The blue seed does not fall in this range here in terms of the temperature. Then we're going to end up with a mushroom. So there's no need to ask for the soil moisture until we know that we're in a correct temperature range. So I'm going to just take this code here and select it. I'm just dragging over, left-clicking and dragging. And then I'm going to use hold down Control and then hit the X key, and that will cut that bit of code out. And you see that the code analyzer here in Eclipse is already complaining. It's already saying that we have some unresolved variables here. But as soon as we come in here inside of this if statement where we have the if temp is greater than or equal to 75 and paste it, and I'm going to hold down Control and then hit the V key to paste, then the Eclipse code analyzer is not complaining anymore. That's now resolved. Still unresolved down here, so let's go ahead and paste in this bit of code down here as well. So Control V once again, and we paste that code in. So now we're not asking for the soil moisture until it actually matters. So let's go ahead and save this, build it, and we'll run it. So we'll put in red for the seed color, and we'll put in a temperature of 65. So that's down below where we get a flower. And it says that a mushroom will grow. And notice how we did not ask the user for the soil moisture. And that's good. We don't want to ask them unnecessary questions if we already know ahead of time that we're not going to get that result. So let's run it one more time, and maybe we'll do it for blue seed. So we'll type in blue, and we'll put in a temperature of 95. And it says a mushroom will grow. So we exercised the second case here if the seed color is blue. All right, so let's take a look at our code and notice how we have this if statement here to test to see if we have a red seed, and then we also have another if statement here to see if we have a blue seed. And you may be wondering what would happen if we change this to an else statement. So that's saying that if the seed color is not red, then it has to be blue. And that may not be the case, right? So somebody could actually input the color green or brown, or maybe not even a color at all. They could input anything. So anything other than red would actually come down and try to execute whatever we have here in this else statement here. So if the temperature happened to fall between 60 and 70, then we would ask for the soil moisture, and if it happened to be wet, we'd output that a dandelion would grow. But they may have inputted, that the seed color was, hamburger or something like that, something that doesn't even make any sense. So we have to be careful whenever we use this else here. We have to know that we have valid input and that we've exhausted all other alternatives. And the only thing else left is this stuff here. That's where we'd how we would use the else statement. So we could, I guess, leave the else in there if we came up here and maybe did something like this. So after we get the seed color, test to see if the seed color is not equal to red and the seed color is, seed color is not equal to blue. If that turns out to be the case, maybe we'll just output to the user. We'll do a cout and then say invalid color selected. Program will terminate. Okay, so we could have some bit of code like this, and then we could do maybe a return 0, and that would actually terminate our program at that point in time. So if we had that, it would actually be okay to have an else statement in here, because if they input anything other than red or blue, it's going to come in here and execute this statement and then do the return 0, meaning it's going to exit out of our main program, or our main function. Notice how we did construct this particular Boolean expression here. We said seed color not equal to red and seed color not equal to blue. You have to be very careful. If we would have used the OR here as opposed to the AND operation, let's notice what happens, because this is a common mistake as well, that someone would put an OR here instead of an AND statement. So with the OR, maybe they type in blue, okay? So blue is not equal to red, right? So this would be a true statement. And we only have to have one true statement in order for this whole thing, in order for this whole entire expression to be true. So we would end up executing this statement here, and that's not what we wanted to have. We needed to have both of these being true. So if they typed in blue, this would turn out to be true, and this would be blue is not equal to blue. That is in fact false. So true and false with the AND operation, the whole expression turns out to be false, and so we wouldn't execute this bit of code here. And that's what we would want to have happen if they typed in blue. So do be careful between using the AND and the OR operations, and test out your logic. All right, so let's see how this works. I'm going to save it, build it, and then run it once again. All right, so we'll type in brown. And it says invalid color selected. Program will terminate. And that's exactly what we expected to happen. Let's go back and run it one more time and make sure it does work if we type in blue. So let's type in blue. And we'll put in a temperature of 75. And it has a mushroom will grow. And that's exactly what we expected, because it did not fall into this temperature range. Let me scroll down a little bit further to get to the blue section. So yeah, it didn't fall in between the 60 and 70 range. So we ended up with a mushroom here. So it's perfectly okay to have the else statement like we have here now, as long as we've validated our input through this condition here. So we provided this conditional statement. All right, so maybe the last thing that we'll do with this program is actually do some input validation for our soil moisture. So much like what we did here for the seed color, we can do similar things for the soil moisture. So we'll come down here and write some code below this. So after we get the soil moisture, we can test to see if soil moisture is not equal to wet and soil moisture is not equal to dry. Then what do we know? We know that we have invalid input there. So we'll say cout and then say invalid, let's see, invalid soil moisture was inputted. Maybe input is a better word to use. And then we'll say program will terminate. All right. So we can do that and then do a return 0. And that actually ends the execution of the program. All right. So it exits the main function, just returns it to operating system control. All right. So we've got that. And that looks correct, hopefully. So the soil moisture is not equal to wet and not equal to dry. That means that we do not have a soil moisture that we expect to make use of. And since we have that bit of code, we could actually go in here and have this if statement here, but have this as an else. So we could change this bit of code and have this as an else, much like what we did before. And we could copy this bit of code here, copy that, and then paste it down here for the blue one as well. Do input validation as well here. And then what could we do? We could take this out and change it to an else. Because we know if we make it past this point here, after this if statement here, we make it past, so this ends up not being true, then we must have the soil moisture being wet or dry. Okay, so that's the reason why we can do that else there. Because if it's not wet, it has to be dry if we've made it past this condition here. Now, one thing that may be bothering you about this code is that we have replication of code segments in several places here, right? So we have this replication of code here and replication of code here. And hopefully that's a little bit unsettling to you as you start programming more and more. Anytime you see replication of code, that should be upsetting. But later on we'll look at maybe being able to get rid of this replication of code and write a function. If we're interested in doing that same operation again, we'll just simply call a function to do that task as opposed to rewriting the same code over. All right, so I think that pretty much wraps up our discussion of Program 4. I guess the last thing we can do is save our program and maybe build it and run it a couple of times. So let's build this and run it. So we'll go ahead and type in red. And the temperature we'll say is 75. And we'll put the soil moisture as, I don't know, let's make up something that doesn't make any sense. We'll just say dirt. The soil moisture is dirt. And hit enter. And it says invalid soil moisture was inputted. Program will terminate. The only other thing I guess we may do is we could just say soil moisture with a space in there. We don't have to use the variable name inside that string literal. So let me change that and put a space in there. And then we can save and rebuild that. So maybe we'll check out the blue and see if it works. So blue, and then we'll put a temperature of 65, and the soil moisture is, we'll say moist, which is not a valid selection. So invalid soil moisture was inputted. Program will terminate. So that's exactly what we expect. So anytime that you're constructing a program and you may have multiple alternatives or multiple paths that you can select through the program, it's good to try to test and exercise all those paths and make sure that the program works. And we certainly haven't exercised all the paths for this particular program. So I encourage you to continue playing around with this program and maybe see how you could improve it. I'm not saying it's perfect.